So let's take the p of 10 to the 8th. P of 10 to the 8th. Oh, good. So we know that the p of something is the negative log. That's why we had to spend so much time reviewing logs, because in order to take the p, you have to take the log. So the only difference between the p and the log is the p is whatever the log would be, but you change the sign. The p is just whatever the log would be when you change the sign. And the logarithm we know is just the exponent on the 10. If we were just taking a logarithm here, the logarithm would be 8. So the p is negative 8. Okay, good. So we simply take the exponent from the 10, but we have to use the opposite sign because taking the p is the negative of the log. Okay, good. So that would give us a negative 8 there. So the p is the logarithm is simply basically the exponent from the 10, and the p is the negative of the exponent on the 10. That didn't give you any trouble, so we can keep going. When you're ready, let's take the p of 10 to the negative 4. The p of 10 to the negative 4. Okay, good. No trouble at all again. So the logarithm would be negative 4. So the p is positive 4. The negative exponent. Well, the negative of this exponent is positive 4. Very good. Now, normally when we're doing chemistry, we don't normally see the p written like this. How do we normally see it written? But what we normally do is we would see, you would know the hydronium concentration is 10 to the negative 4, and then the question would ask you, what's the pH? Normally they would say hydronium concentration is 10 to the negative 4, what's the pH? But you see, that's the same exact problem as I just did here. This is just a shortcut for writing that, because the pH really means the P of the hydronium concentration. H in pH just stands for hydronium concentration. This is important to know. pH just means the P of the hydronium concentration. Well, I just said the hydronium concentration was 10 to the negative 4. So when you're taking the pH here, you really are taking the P of 10 to the negative 4. So this is the mathematical operation we have to be able to do, taking that P. And this is something that's going to come up on almost any acid or base problem. Almost any acid or base problem, we are going to figure out the hydronium concentration, but then we have to figure out the pH that comes from that. And the way to do that is to take the P of that hydronium concentration. Good. Okay, so let's take the P of 1. It might be better to write lowercase p's, because usually, remember when you see people write the pH is usually written like this, right, with a capital H and a lowercase p. Actually, I think sometimes people do use an uppercase, but it's usually better to use a lowercase p for this operation of taking the p.
I was just trying to think of 1 times 10 to 0 is actually, if I say 10 to minus 0, it's not less, but it is equal to 1 times 10 to 0.
Okay, so it looks like you're getting a little confused about that step. So we have p to the 1 here. Now, you saw that we need to express this as a power of 10. We want to express this as a power of 10. Now, the way you expressed it was like this.
Right.
P of 1 times 10 to the 0. So that's perfectly accurate. 1 is 1 times 10 to the 0. And then you tried to use the technique we used before of using references.
Right.
You tried to use the technique of references, but you're struggling with this one over here because I think what you're saying is this is not less than this, is it?
Yeah.
In fact, it's just equal, right? Well, that's even better, right? Remember, we're only approximating as a last resort. It would be even better if we knew exactly what to compare the number to. So it's even, the fact that these are equal means we don't need to bother with the approximation anymore. So how do we take advantage of the fact that these are equal? Well, we take advantage like this. Just drop the 1. 1 times 10 to the 0th power is just 10 to the 0th power, right?
Right.
These are the same thing. Well, do you know what is the p of 10 to the 0th power?
1.
Now take your time on that. What's the p of 10 to the 8th?
Minus 8.
Yeah, it's just the negative of the exponent.
Minus
Take your time.
1.
What's the p of 10 to the 8th?
Minus 8.
Yeah, it's just the negative exponent. What's the p of 10 to the negative 4?
It's 4.
Yeah, it's just the negative of the exponent. So negative 1 times 8 is negative 8. That gave us this. Negative 1 times negative 4 is positive 4. That gave us this. Well then, what's the p of 10 to the 0th power?
Well, if 10 to the 0 is 1.
That's true, but that's what we started with, right? We started with 1.
Right.
We want to stick with this. So let's see. Once we have a power of 10, we just take the exponent and change its sign.
Well,
Right.
it's 0.
That's right. Okay, there you go. So let's review that. So basically all that you did here is you took this exponent and multiplied it by negative 1, right? And you took this exponent and multiplied it by negative 1. What's negative 1 times 8?
Minus 8.
That's what gave us our answer. What's negative 1 times negative 4?
Positive
That's what gave us this answer. What's negative 1 times 0?
1. 0.
That's what gives us that answer. I guess one thing that's confusing here is you can't really think of this as changing the sign on the exponent because 0 doesn't have a sign.
Right.
But what we're really doing is just multiplying the exponent by negative 1 each time. Well, negative 1 times 0 is just 0. Okay. All right, well, that one gave us some trouble. Let's see here. So you correctly saw that we could rewrite the 1 as like this. And then what gave us some trouble was, first of all, you were saying, gee, how can I approximate this? 10 to the 0th isn't smaller than this. Well, that's good. It's good when we can say something that's exactly equal to what we're trying to take the exponent of. So we can just say, we can just drop the 1 here and say this is just 10 to the 0th. Let's actually write this out a little bit more to make this even clearer. What does it mean when we take the p of something? Well, that's the negative log. So the p of 10 to the 0th should be the negative log of 10 to the 0th. When we're getting confused, it's always best to write down every single step. The p of 10 to the 0th should be the negative log of 10 to the 0th. That's just the definition of this p operator that we have down here. The p of something is the negative log of that thing. And now we can step by step simplify this. What is the log of 10 to the 0th? What is the log of 10 to the 0th?
What is the log?
Yeah. What is the log of 10 to the 0th? I want to simplify this part of the expression. So what is the logarithm of 10 to the 0th power?
1. Minus 1.
Take your time.
Oh, it's 0.
That's right. Remember, the whole idea of a logarithm is that the logarithm of a power of 10 is just the exponent on the 10. The logarithm of a power of 10 is the exponent. What's the logarithm of 10 to the 5th?
It's
5. What's the logarithm of 10 to the negative 6? Negative 6. And we also, I think, reviewed this example over here. What's the logarithm of 10 to the 0? 0. All right, so what's the logarithm of 10 to the 0? 0. Not 1 or negative 1. 0. And I still haven't dealt with the negative sign yet. All I've done is I've taken out the log and replaced it with 0. But how can you simplify negative 0? What is negative 0?
0.
It's just 0. Okay, and that gives us to the same answer we had said before. The p of 1 is 0. Okay. All right, well that's one that looks like you want to highlight in your notes and go back and review.